Hey, ChemStars, this is Mrs. Vanderlei bringing you ChemStar video where you are the star. All right, so we are continuing on our topic of measurements and calculations, and we really need to get right into the metric system here. That's our units of measurement. And this is not the first time you've seen metric, but it won't be the last time either. We're only going to use metric throughout this year. So, if you're not used to it, go back and look this over again. It should have, you've seen it before, and really try to get it if you can. All right, so we're going to be using the SI, which is French from Système International. The English would say the International System of Units. Real quick, it was actually Napoleon Bonaparte who came up with the idea that we need a unified system of measurement. So he had a group of quote experts come up with how can we have so a way to measure things that every town could have, because back in prior to this, every town had like their own number of rocks, if you will, for a unit of mass. So if you're going to go buy bread in one town in Paris or one town in France, it would have its base unit would be this pile of rocks. And if you go to another town in France and try to buy some bread, they're going to have a different pile of rocks for their system. So length is the same thing. There was a lot of boundary disputes because no one had a actual unit of length. Back in those days, you'd use your own feet to measure feet. And as we know, not everyone's foot is the same length, okay? So this group of experts that Napoleon came up with the idea that, well, how can the whole world, in a sense, know what's going on? Well, what they did, they took the Earth, and I try to draw a picture of the Earth there, rotating on the axis. And this line here is the equator, if you hadn't figured that out yet. And so what they did, these smart guys from Napoleon, is they took a quote line. Oh, I'll make it red. How's that sound? So they took a line from the North Pole to the equator that went through Paris. And that's actually called the Rose Line, believe it or not. If you're a Dan Brown fan from the Da Vinci Code, they mentioned the Rose Line. So anyway, here's a line from the North Pole to the equator that goes through Paris, and they divided it by like 1,000,000 equal sections. So 1/1,000,000th, actually I think it's 1/10,000,000th. 1/10,000,000th of the section, they said, voila, this is a meter. And so that is where they began coming up with a common system for everyone that everyone can agree upon. What they did next is that they said, we're going to take a tenth of this meter, which would be a decimeter, and they made a cube out of it, and they said this is going to fill it up with water, and we're going to call this 1 kilogram. And so they tried to make it so that everyone could, if everyone had a meter stick, then they could come up with these others. All right, so you're probably familiar with this. The meter symbol is a small case m. Mass, it was originally gram, but now it's a kilogram. What happened is that, so in the early 1800s, Napoleon's group of experts came up with these. There was a council in the 1960s that kind of revisited the SI units, and so they kind of tweaked it somewhat. And also, interestingly enough, they said, well, by the 1980s, the entire world should be in metric. Well, guess what? There's only 3 countries in the world that don't use metric, and the United States is one of them. All right, so anyway, so they revamped it and made it the kilogram. Temperature was originally Celsius, and now it is Kelvin. And what they used here is that they said, okay, we're going to make the Celsius scale where water freezes, it's 0, and where water boils, it's 100. Okay. The problem is with a lot of the math, we can have negative temperatures, but the math doesn't work out with negative temperatures. So they tweaked it. Now they have the Kelvin scale, which absolute 0 is the lowest possible. So you have no negative temperatures. A second. And they defined that. I forgot how they defined it, but now we talk about the radiation emitted by cesium. All right, and they can look at the wavelength and count, and however many wavelengths pass through this would be 1 second. A mole is amount of substance. And I kind of oopsied in the last one where I said, oh, remember we talked about the mole? No, you haven't done it yet. So a mole is the amount of substance. And we define this is going to be much more detail back in chapter 7, where we say 1 mole is that 6.02 times 10 to the 23rd number of anythings, all right? So number of atoms, it would be a mole of whatever you're working with. And the last two, we really don't talk about here in chemistry. This is more of a physics things. Luminous intensity would be a candela, and electrical current is an ampere. You may have heard of it as amps. So I actually kind of faked out a little bit of the abbreviations. I will use SEC, so hopefully it's less confusing, and I'll use AMP as well. So I know they're wrong, but I think as the students look at them, it's a lot more intuitive if you see SEC or AMP. Is like, what are we talking about? So anyway, like I said earlier, when you look at a meter stick, it's a pretty long thing. Think of it like a yardstick. We'll look at it in class and you'll see a real meter stick. And, for some things that's very appropriate, like if I want to know the length of the room is, but if I want to talk about, the distance between here and, let's say, New York City or something, I probably wouldn't be talking about meters. I'd probably be talking about kilometers. If I want to know the length of the width of a, I don't know, a mechanical pencil lead, all right, you probably wouldn't talk about in terms of meters. You'd probably be talking about in terms of millimeters. So what Napoleon's group did is that they divided up these base units into factors of 10, okay, and that's where these came from. Let me extend my page a little bit. So that's where these came from. So my base is here in the middle. And then for you guys, we're going to be using kilo, hecto, deca, deci, centi, milli. So this is my base unit, 10 to the 0. That's why we learned a little about exponents in the last section. So we were talking about them again. So what is 1 divided by 10? It's 0.1 or 10 to the negative 1. What's that divided by 10? 10 to the negative 2, 10 to the negative 3. If I want to get bigger, I go to the left, all right? So a deca is 10 meters. Hecto is 100 meters. Kilo is 1,000 meters, okay? And they've expanded it even more, but notice I put this in bold. This is what you are expected to know, okay? And the other ones maybe are just, somewhat familiar. So if I go even smaller, it's micro, 10 to the negative 6. Nano is 10 to the negative 9th, and we will be using nano in later chapters. We have the picometer down here. We probably won't use that at all. If you want to get in the bigger area, we have a mega is a million. Hey, it's kind of like those lottery tickets that you see advertisements for. It's the mega millions. Well, it's kind of redundant. They're saying million, okay? Ooh, wouldn't it be awesome to be a trillion? And then we have a giga and then a tera. So these might be more familiar with you with the computer terminology of like gigabytes and terabytes. They all came from this basic unit here, okay? Well, let's go ahead and turn the page. Well, it's not going to be enough just to know these prefixes. We're going to have to convert these, okay? And so what I wrote here, and if you'd like to write it too, the bigger unit gets a smaller number and the smaller unit gets the bigger number. And I say this to help you keep straight of how to move your decimal point, okay? So if I look here, it says 1 meter is 10 decimeters. So if I'm going to go from 1 meter to a decimeter, I'm going to go this direction. So the smaller unit, I need more of them to make up 1 meter. So there's 10 decimeters in 1 meter. If I go 2 over 1, 2 over, that means that there's 100 or 10 squared centimeters in 1 meter. Or I can go the other way. So if I wanted to find mega, 1, 2, 3, 4, 5, 6. That's why there's these little blocks here, because they are placeholders. So I go 6 over. Now, wait a minute. The smaller unit needs the bigger number. I'll say it again. The smaller unit gets the bigger number. So I know there's a factor of 6 difference here. So if I put a 1, then this number, mega, is much bigger. Then I have to divide that by 10 to the 6. So this is 1/millionth of a megameter is equal to 1 meter. Or if you look at it this way, 0.1 meter is 1 decimeter. Yeah, so the bigger unit, the meter, gets a smaller number. The smaller unit, decimeter, gets the bigger number, the 1. And that really works down here, where we say that 1 megameter is equal to 1,000,000 meters. Okay, so keep that in mind when we are doing these problems here. Okay. Okay, so just like what we did with scientific notation, we were moving decimal points over. We're going to do the same thing again here, okay? So watch what we do. We're going to go from the meter, which is a base unit right here, to hecto. So what am I doing? I'm moving it 1, 2 over to the left. Did you catch that? So I'm going to start here. This is where your meter is. It's your base unit right here. So I'm going to start with the meter because that's what my given unit is. And I'm going to go to the hecto. 1, 2 to the left. So I'm going to move my decimal point 1, 2 to the left. So I got 0.238, okay? So just like what we did in the sign notation, we're moving those decimals. All right, so what about the next one? 39 grams equals how many centigrams? So here is my base unit, here's my grams. So all those units that we saw on, above, the mole, the meter, the grams, the seconds, the amps, that kind of thing. So this is my base unit. So I have 39 grams. I'm going to go to centigrams, right? So this time I'm going to go 1, 2. There's centi right here. I want 2 to the right. So I need to move my decimal point. There is no decimal point. Well, it's after the 9, isn't it? Move it 2 to the right. So my number got bigger, didn't it? So I got 3,900. Now let's just pause here for a second, all right? So in letter A, which is my bigger unit? My hectometer is bigger than a meter because it's over here. Hecto is bigger than a meter. So my bigger unit has a smaller number. Meter is smaller, it gets a bigger number. Same thing over here. Gram and centigram. Well, which is bigger? Well, the gram is bigger, it's to the left, okay? So a centigram is smaller, it's to the right. So notice that this is a bigger number with the centigrams, 3,900 versus 39 with the gram. All right, how about the next one? We're going to do some seconds to kiloseconds. All right, I need to scroll it up. So I want to go from seconds, all right, to kiloseconds. So it's 1, 2, 3 to the left, isn't it? So I'm going to move the decimal place 3 to the left. So wait a minute, that number just got a lot smaller. I have to put some zeros in, don't I? I know this is kind of hard to do. So I need to put in some more zeros, don't I? Well, yeah, I do. So this number ends up being really, really small, right? So I have to move my decimal place over 1, 2, 3 to the left. So I'm going to ask you again, my kiloseconds is a bigger unit than a second. Well, notice that my number is smaller with the bigger unit. My smaller unit gets a bigger number. So 0.0842 is actually bigger than 0.0000842. All right. So now let's do mole and millimole. All right. So I have mole and millimole. Here's my base unit. All right. Here's my base unit. And I want to go to milli. So it's 1, 2, 3 to the right. So I'm going to move my decimal place. This is Vanderbilt. There's no decimal point. So, okay, it's behind the 6, and I'm going to move it 3 to the right. Well, what do you think I'm going to have to do? Well, I think I'm going to have to add some more zeros, don't I? So that's where this number, I added 3 more zeros. So now I have kilo amperes and microamperes, all right? So I need to go from kilo to micro. What does that mean? That you don't always have to be on the base unit. You can go from any unit to any unit, but watch what happens. So I'm going to start here at kilo. Ready? 1, 2, 3, 4, 5, 6. Keep going. 7. Oh, geez. Sorry about that. 7, 8, 9. So I have to go 9 to the right. Hopefully you figured that out. I know for whatever reason my board was kind of weird. So I want to go 9 to the right. So holy cow, ready? Yeah, go start here and go 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, you might have figured out you have to add 9 extra zeros, don't you? And so here, let me erase this real quick. So this is what you end up getting. Woo! Hopefully you wrote small. All right, so remember what I said. The smaller unit gets the bigger number. The bigger unit gets the smaller number. You had to add 9 more zeros to get to micro. And finally, we have bytes to gigabytes. Hey, this sounds like a computer thing, doesn't it? All right, so here, let me erase this real quick. So you want to go from bytes, which is sort of a base unit. Napoleon's group did not have computers back in those days to know the difference, right? So we'll just use bytes as a base unit too. So here's my byte. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want 9 to the left. All right, so you're going to take this and go 9 to the left. All right, so watch. I'm going to actually go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what do I end up with? I end up with 128 gigabytes. Now, hopefully that makes some sense. What I'd like you to do now is do the next 6 on your own. Let's see how you do. So please pause this and see what you get. Well, hopefully you got these answers. I could have made a mistake, but I don't think I did. To go from centi, no, oh, I did make a mistake. Hang on, let me fix it. Okay, phew, fix that one. So you go from a candela. That's not a centi, that's a candela. How did I know that? Well, I got tricked up too. I hate to say that. Because there is no base unit that's a D. All right, the base unit is a CD. All right, so the base unit is a candela, and I have to go 2 spots to the left for hecto candela, and so I move my decimal point over twice to get hecto. For kilograms to grams, I had to move my decimal place over 3 spots to the right, so I got 880. To go from millimole to decimole, I had to move it over 2 spots to the right, or excuse me, to the left. I had to make it smaller. So there's my 2 spots, so it's 7,500. D&E I made so that you can see the difference between deciamps and decaamps. Amps, excuse me, not ants. So for amps to deciamps, I have to go 1 spot to the right, so I had to add a 0. To go from amps to decaamps, I had to go 1 spot to the left, so I had to take away a 0. And finally, nanometer to meter, I had to go 9 spots to the left, so I got 0.45. Okay, and so that is where I quit. And again, we will be practicing this in class. Be looking for an objective check. If this isn't making much sense, you know, go back, look this over again, watch the video again if you need to, and make sure you have this. This is really important, okay? So I'll just leave you with this. Don't wait to be great. See you next time. Bye-bye.